Hi everyone, we're Study Smart Tuition, achieving high grades the smart way. So today's video is a walkthrough of a GCSE grade 9 physics question. So we obtained these questions from the CGP workbook and they based this off the AQA syllabus. So today's one is an energy question, which involves rearranging the specific heat capacity equation and using the efficiency equation. So this is a grade 9 question which involves a bit more thinking, more problem solving. So please give this a thumbs up if you've enjoyed it, and please subscribe. And also leave a comment down below if you have any further suggestions or any questions about this video. Also please head over to our website, Study Smart Tuition. We're an online tutoring service, so if you're interested in getting tutored for GCSE and A-levels and also higher education and primary, please have a look. Hope you enjoy the video. So starting off with this question. A solar panel is attached to an insulated tank that contains 3,000 kilograms of liquid X. As shown in figure 5, the solar panel absorbs energy from the sun during the day and transfers some of that energy to liquid X. Okay. The useful energy that is transferred to liquid X in one day is 47.5 megajoules. This causes the temperature of liquid X to increase by 4 degrees Celsius. Okay, so if we look at this question, we have the mass, we have the amount of energy transferred, and the change in temperature. Okay, so when I look at these measurements, it reminds me of the equation energy equals mass times specific heat capacity times the change in temperature. So we know we're dealing with something with energy change. But let's carry on reading the question. So, calculate the specific heat capacity of liquid X. Okay, so we need to work out specific heat capacity. So we need to rearrange this equation. So just in case for some of you that aren't really confident with rearranging, your aim is to try and get a C on its own. So check out some of the maths videos that will come out in the future, and also head over to our website studysmarttuition.com. Anyway, so our aim is to get a C on its own. So what's in the way of C? We have M in the way, and we also have T in the way, and both of them are being multiplied to C. So the opposite of multiplication is division. So because we want to move the mass and the change in temperature to the other side, we're going to divide E by both of those things. So E divided by M times change in temperature equals specific heat capacity. Okay, so let's substitute each of these values in. So for energy, we have been given energy, but the units are in megajoules. And we know that the SI units for energy is actually in joules. So what you need to know, it's really important that you know how to convert between megajoules and joules and kilojoules and joules. So I'll make another video on prefixes and units. But what you need to remember is that in 1 megajoule there are 1 million joules. Okay, so we multiply 47.5 by a million. Okay, so let's say that instead of writing it out, let's just write 47.5 times 10 to the power of 6 here. Obviously this is not in standard form, as you have covered in maths, but this should make this should help you type it into the calculator real quick. So now we need to divide this by the mass, check for the units again. Good, so it's in kilograms, so 3,000 times the change in temperature, which is in 4 degrees Celsius. Okay, so if you type all of that out in your calculator, you should get 3,000 958.3 recurring. Okay, so now they said make sure you read every part of the question. So the last part of this question, it says give your answer to 3 significant figures. You can actually lose marks if you don't pay attention to such detail. So 3 significant figures: first significant figure, second significant figure, third significant figure. And this is therefore because 8 is greater than 5, we're going to round up, so it's going to be 3,960 joules per kilogram degrees Celsius. Okay, so that's the first part of the question. Alright, let's move on to the second part. Okay, so the question reads, the solar panel is in the sunlight for approximately 12 hours per day. The average solar power that would be incident on the solar panel is 5 kilowatts. So, meaning that the whole tank is, well, the solar panel is in the light for 12 hours per day, and the average solar power, so all the power that actually hits the solar panel is 5 kilowatts. Okay, so that's the total that actually hits the solar panel. Estimate the efficiency of the panel. Give your answers to 2 significant figures. Okay, so efficiency. The equation for efficiency is useful output divided by total input. Okay, so let's identify what the useful output is. So give yourself 30 seconds to identify what the useful output is. Okay, so the useful output is 47.5 megajoules, because it literally says the useful energy that is transferred, so the actual amount of energy that is transferred to the liquid X, because that's what we're trying to heat up, is 47.5 megajoules, or 47.5 times 10 to the power of 6 joules. Okay, so let's label that 47.5 times 10 to the power of 6 joules. Okay, remember this is in joules. Now, how do we work out the total input? Seems like we have no information to work out the total energy input, but this is why they've given us this information. We've been given the power, and we've also been given the time. What equation links power and time together? Power equals energy over time. Okay, so remember this, power equals energy over time. Joules per second is the same as watts. So that means energy equals power times time. Okay, remember this is let me change the colour of the pen. This is in kilowatts. So kilo means 1,000, so this is actually 5,000 watts. Okay, so energy 5,000 times, we can't do 12 hours because the SI unit for time is in seconds. So the number of seconds, you just do 12 hours times 60 to convert it into minutes, times 60 again to convert it into seconds. So that should give us 43,200 seconds. So we have 43,200 seconds. To work out energy, we do power times time. Okay, so what is that? If we put that in the calculator, we get 2.16 times 10 to the power 8 joules. Alright, so let's put that into this equation. So let's do 47.5 times 10 to the power of 6 divided by 2.16 times 10 to the power of 8 joules, and that should give you 0.2199 something. Okay, but we need to round it to two significant figures. So our first significant figure is 2, then it's 1, so we should stop here. 9 is a bigger number, so we round up, greater than 5. Anything greater than 5 you round up, so that should give us 0.22. So the efficiency is 0.22 or 22%. Okay, so that's how you answer a grade 9 energy question, so specific heat capacity and efficiency. So please leave a comment down below if you need any further help or any questions about this, or if you have any further suggestions of topics that you want us to go through. And please subscribe and press the thumbs up. Also, have a look at our website if you're interested in our online tuition services. Thank you for watching, and hope to see you soon in another video.